What is the number one most underrated way to find vulnerabilities and to test your smart contracts and even to find vulnerabilities in your tests? You might be guessing, fuzzing, invariant tests, symbolic execution, static analysis. And if you guessed any of those things, you would be wrong. The most underrated way to find vulnerabilities in smart contracts and test the robustness of your test suite is, in my opinion, this one type of testing. Now, of course, that's absolutely not to say that fuzzing and invariant tests and symbolic execution, static analysis aren't amazing tools that you should also be using in tandem with this thing that we're going to go into in just a minute here. But I think that there's really a lack of interest or just awareness, as far as what I can see, for this type of testing. And I think it can be really powerful. And I actually think that there's a ton of room for improvement in the tools that we have at our disposal to actually make this type of testing even more powerful and even more widespread and available to all types of smart contract code bases and teams and security researchers, et cetera, et cetera. So this is my attempt at sharing why I think this kind of testing is so cool. And then hopefully out of this, maybe we can get, just some more awareness around this type of testing technique. And then maybe even hopefully we can improve some of the tooling that is available to folks to actually carry out this sort of testing. All right, so what is this one method of testing? I've been keeping you guys hanging. It is, of course, mutation testing. And so in this video, we're going to talk about, what is mutation testing? Why do I like it? Why do I think it's a little bit underrated right now in terms of, how much it's used and talked about? And then we're going to look at, okay, how can we actually use it in a project? We're going to look at a very basic project. We're going to look at two different ways in which you can use mutation testing. We're going to look at two different packages that you can use to help you mutation test. They're going to talk about, where it needs to be improved, where the tooling is maybe a little bit lacking that needs to be developed and worked on. So we've got a lot to get into. So without any further ado, of course, my name is Owen, and about, over 2 years ago, I guess at this point, I co-founded Guardian Audits, and ever since then, we've uncovered hundreds of high and critical vulnerabilities across probably at this point, multiple hundred smart contracts across dozens of smart contract security reviews. And so, of course, my goal with this channel, everything that I put out, is to take everything that I've learned over all of those smart contract security reviews, distill it down, and give it to you so you can ultimately become a much better smart contract security researcher, a smart contract blockchain engineer, and use some of these best security practices for yourself, whether that be for, finding bugs, using it to secure your own protocol, et cetera, et cetera. And so I hope that especially this video here on mutation testing will help you go forth and increase your security posture. But with that being said, let's get into mutation testing here. All right, awesome. So first of all, let's just dive right in and let's address, firstly, what is mutation testing? Then we're going to talk about why I think it's such a great thing. And then we're going to have a look at our first package using mutation testing. That's going to be Gambit. And then we're going to look at a second package that we can use to mutation test our code, and that's going to be Vertigo. And then after all of that, we'll talk about, hey, here's where I think that we can actually improve upon the existing tooling. Here's how I think we can improve and adopt this into more code bases and get it more widely used and more accessible to more security researchers. And after all that, hopefully this just either, shows you something new that's a little bit interesting, maybe even start using mutation testing, and hopefully you can find and uncover some bugs using mutation testing. So that would be my greatest hope after watching this video. But even if you just learned something interesting, I'm more than happy with that as well. All right, so to start off and just understand what is mutation testing, I've got a basic ticketer contract pulled up here. We're going to be mutation testing our ticketer contract. And you can see we've got our corresponding tests for our ticketer contract here. There's really not too much there, but we can see in our ticketer contract, there's only two functions here. We've got buy ticket and we've got owner collect. So let's see, what are we going to achieve with mutation testing? Well, we're not going to exactly test directly our ticketer contract. We're actually going to be testing our tests. So we're going to be finding vulnerabilities, if you will, with our tests. So you can see in our test file, we've got this test by ticket, we've got test owner collect. So really basic tests of our ticketer contract here. And we can see if we run forge coverage here, we even have, maybe decent test coverage. We've got 100% coverage of lines. So we might say like, hey, we've got good tests. But how do we actually measure how thorough and exact our tests are? And how can we measure how effective our tests are at actually uncovering bugs and preventing bugs in our code base? Because, it's one thing to say, hey, well, we have 100% line coverage in our tests. And it's another thing to say like, hey, our test suite catches 100% of bugs, right? So while mutation testing won't guarantee us that, hey, your test suite catches 100% of possible bugs, it does give us a indicator and a system of measurement to see where some of our blind spots are when it comes to detecting bugs. So how does it work? Well, what mutation testing will do is, just like the name implies, it will come in and it will mutate our contract here. So like my ticketer contract, it will find random lines in a function. So like, let's say this if statement here, if amount equals 0, then we're going to revert because we don't consider that to be a valid amount. It will change this line. So let's say we have a condition here. It might just change this condition to amount not equal to 0. And it will see, did your test suite throw an error as a result of this? Because clearly, if we intend this to be 0, then changing it to not equal to 0 is a bug, right? So our test suite, which is sort of the specification of our smart contracts, should scream about this. It should have an issue with this. So if it does pick that up and it reverts once we make that mutation, then good, our test suite passed that test. But let's see, what if we put false here? What if we put true here? What if we change this amount times price to amount divided by price or amount plus price? Do we catch all of these different potential bugs when we make those mutations? And we'll see exactly how this process unfolds and what it looks like in just a second. But the reason I really love mutation testing is because you can finally get a way to actually measure beyond just code coverage, which I think is, it is a metric of how robust a test suite is, but it's maybe not the greatest. As you can see, we've got 100% code coverage here, but we've got, maybe potentially a critical vulnerability here. I don't know if you've already seen it, but one does exist here. But so we can clearly see that 100% test coverage is not going to catch a lot of things. But if we have 100% mutation coverage, we can be sure that we're catching a lot more. But as we'll see, we're still not going to be able to catch everything. And I'll show you exactly what kind of things can slip through the cracks, even for mutation testing. But nonetheless, regardless, I think having a way to measure the bug catchability-ness of your tests is extremely valuable, and it gives a really good feedback loop for how good your tests are, where before, without mutation testing, the feedback loop for how robust your tests are was really not that great, right? You're either just looking at like, okay, here's a percentage of lines coverage, but you're not really looking at a percentage of bugs caught. So that's why I love mutation testing so much, because I think it's very important to be able to measure. If we cannot measure things, then how can we really improve, right? And I think that's what makes a big part of security, and especially Web3 security in general, very hard, is that you can't necessarily measure how secure a protocol is. But this mutation testing gives us one such data point, which is in fact very measurable. It's very good at taking the abstract, the hard to measure, and putting it into some kind of data point, which I think is valuable, right? If you could crystallize how much security your test suite gives you, this would be at least one way where you would do that. But beyond all of that, let's talk about now actually doing this. So let's see, we've got a general idea of what mutation testing is, what it's going to do, but let's actually put it into practice and see what it looks like in real time. So of course, the first mutation testing tool that we're going to use is Gambit from Certora. So first of all credit to Certora for putting together Gambit. Really what Gambit is going to do is it's going to go ahead and parse this ticket or contract. It's going to compile it using solidity and then go ahead and parse it. And then it's going to come to different nodes where it's like, oh, if this is a condition node, or if this is a operator or something like this, then we're going to try different stuff, and we're going to enumerate a bunch of different versions of this contract, and we're going to save each of those versions as a individual mutant. So then we'll have a bunch of different versions of this ticket or contract, and all of them will have one singular defect in them, and then we will be able to take our tests, test them against one of those defects, and see if our test suite caught them. So the first step to getting started with Gambit is going to be, first of all, to get the actual binary for Gambit. So you can go to this releases link right here, and you can grab the respective binary. I've already got it. I've already renamed it and put it into my path. So I have the Gambit function here, or the Gambit binary is right here. And you can see we've got some basic commands here. We're going to be using the mutate command, and this is going to actually go and parse our contract and make all those different versions of it with the defects, like I said. So before we do that, I'm going to create a config file. So we're going to go gambit config.js, and in here I'm going to put a JSON list object, so you can have a list if you want to have multiple contracts that you are mutating. In our case, we're just going to put one. We've got a path to our ticketer contract here. I'm sure a relative path would work here as well. I've just got the absolute. And then you can see you can put remappings in here, stuff that's pertinent to the compilation of your contract and everything like that. In the config file, I think, it's just a little bit easier to put this stuff in a config file than typing it out through the command line, which you can also do. But we're going to go ahead and we're literally just going to run this. We're going to get our mutants. And to do that, we're going to run gambit mutate --JSON. We're going to specify the path to our gambit config. And then we're going to let that run. And we're going to see we generated 14 mutants in 2.67 seconds. So let's go ahead and let's come back, and we'll see now we have this gambit_out directory, and we can see our mutants here. We've got 14 different versions of this ticket or contract. So we can have a look at like the first one here, and we can see here we've got our mutation. So one nice thing that it does is it adds a short comment about what is the mutation that was made. We took this condition, which was amount equal to 0, and we just made it true. Okay, so now if we test our test suite against this version of the ticket or contract, we should get a revert, right? Ideally, this should revert, and it certainly will, because when we call by ticket, it will just revert, and that will be unexpected if we're providing, a real valid value amount. So our test suite as it is right now, it should detect this mutant. But as we can see, of course, we've got, many others. So we've got a mutant 2 here, which will put this as false, which might be one that is more easy to miss, but we'll see which ones our test suite actually hits or misses. So what I've got here is I've got a quick script here, just a quick JavaScript script here to go ahead and basically iterate through all those mutants and then take where they are right now, put them into our source directory, and then run our test suite against them. And we'll see which ones were actually, caught and which ones were not caught by running all of those mutants. So I'll go ahead and I'll just run this script. We'll run the mutation test. So we're going through, we are running the tests for each one of these mutants. Let's see how we do. How do you think we're gonna do? Probably not too well. If you saw, we have 2 tests. Okay, cool. So we've got 4 mutants, which were undetected, which is actually pretty good. We got 8 out of 14, but 4 of them got through. So let's go ahead and check out what are these mutants. Let's see, what did we miss with our test suite? So first of all, let's have a look at our tests just so we can be familiar with what we're actually working with here. Let me just slide this. So we've got test by ticket and test owner collect. So 2 very basic tests. This one is just, Alice is buying a ticket. She's sending 1 ether and she's buying 1 singular ticket. And then we're just asserting, hey, she bought 1 ticket. Cool. And then the owner collect, if Alice buys 1 ticket, then the owner should be able to collect that and actually get that money. Cool. So those are 2 very basic tests, and they were enough to catch 8 out of, how many was it? Or 10. 10 out of 14, because there's 14. So 10 out of 14 were caught by those 2 tests. Let's see which one. So I believe number 2 here is the first one that was undetected. So let's see. Yeah, this is the mutation where we took a true condition and we turned it into false. So this is understandable how we wouldn't have caught this because we don't have a specific test for when the amount is equal to 0. So here I've just added a test where we test that the 0 amount here was actually bought, and so we expect this to revert, and then we expect the bounces to be the same. And so let's see, we can go ahead and run this again. We can run our mutation script, and we can see now we should have gotten a failure for that number 2 mutant, and we should no longer see it here. And there we go. We see mutant 2 is no longer undetected. So now we're detecting that mutant, and that bug would have been caught if there was a bug with that particular condition. So let's see, what's the next mutant here? Let's check out mutant number 4. Okay, cool. So this is if the amount times price is not equal to the message value. So we don't have a test that's asserting that this validation actually makes sense. So I've just added here a test specifically for a invalid amount. So I'm trying to buy a ticket without sending any value here. I'm trying to buy a ticket with half an ether, with 1.2 ether, all invalid amounts. And so now if we run this mutation script again, now we should see that this number 4 here never passes. So we can see now we're down to just 12 and 14 are undetected. So let's see, what is number 12 that they're getting us on? Okay, cool. So at this point, we are not effectively catching that this ticket bounces if it's ever not equal to just 1. So if our amount is always 1 here, which it is in our test suite, that is causing a blind spot because they can just change the amount to 1 and it doesn't really make a difference. So in this case, I actually want to try, let's just go ahead and write a fuzzing test for this. So let's write a version of like test by ticket. We can call it test fuzz by ticket. And let's make it, we need to vm.assume. I'm going to not let GitHub Copilot take over here. But by the way, definitely go check out GitHub Copilot. This thing is pretty crazy. I'm not going to lie. Crazy effective. Okay. So we'll take in an amount, so that's what we're going to be fuzzing. And then we want to assume that the amount, we want to assume it's not equal to 0 because we've already established that's invalid. And then also let us make amount, let's just keep it less than 1,000 individual tickets that we're buying just to keep it to some reasonable range. We can make it 10,000. Okay, so let's go ahead and we need to specify, okay, how much are we going to be sending? So amount to send here is going to be the amount times 1 ether. We can see the price in the ticketer is 1 ether. So for every 1 ticket I buy, I need to give that amount of ether. So that's the amount to send. We need to vm.deal to Alice amount to send, and we need to pretend to be Alice, and then we can buy the ticket with the amount to send. That should be the right amount to send, and then we can assert that Alice has that ticket or balance, and then Bob has 0. Bob, there's no reason for Bob to have any in this test. And then I think maybe one last thing that's maybe interesting is exactly what GitHub Copilot recommended, which is that the balance of the ticketer contract should be the amount that was sent. So all of those things look good to me. I'm just going to run this test just to make sure I didn't mess it up somehow. So we're going to do forge test, match test. We're going to run our fuzzing test here, and we're going to see that it did indeed pass with 10,000 runs. So that's great. So let's go ahead and run our mutation test, and let's see if we caught all of them. Do we still have any remaining after even implementing a fuzzing test? Let's see. So even after fuzzing, we've got a mutant here, mutant number 14, which is undetected still. So let us go ahead. Let's go check out the mutant number 14. Let's see, what is this case that we still have not caught with fuzzing tests, with, error cases tests. Everything seems to be covered. Let's see. So what we've done here is we have taken this. Oh, if it's not successful, then we go to false. So we're never testing this failure to transfer the ether case. So let us go here, and I need to implement a test case where the ether cannot be transferred to the owner. Okay, and I've just implemented that here. Just a really easy way that I decided to implement that was to etch the code of the ticketer, which does not have a receive or a fallback function at that owner address. And it should be caught now. Let's see. So run that script again. Let us see. We should have now passed all of the mutants. Let's see. And now we're seeing, congratulations, all mutants are detected. So now if we run forge coverage, so if we're just listening to the number of lines covered by some like a coverage script, then we would have been like, okay, we're pretty well tested. But as we saw, there's 4 different test cases that we had to implement here, and one of those was a fuzzing test to actually fill out all of the mutation coverage, if that's a term. Maybe we'll coin that term here, mutation coverage. And so now our test suite is giving us a lot more verification, a lot more robust assurance on the behavior of our code, and that our specification of our test suite is actually pretty particular about how our code is. So that's all fantastic, but now let's have a look at a second way that we can go ahead and use mutation testing. Maybe we don't want to have a script that we have to use to actually go ahead and use the mutants, which, by the way, I'll go ahead and share this really, really simple bare bones script just so you can have it as well if you're interested in running mutation tests. We'll make that available in the description below. I'll just go ahead and provide this entire repo for you guys if it could be helpful to you. But let's see, how can we do it without having to write our own script that moves stuff around? Well, this is where the package Vertigo comes in, which is maintained by Jeffrey at Rare Skills. So credit goes to Jeffrey for currently maintaining Vertigo-RS. And then, of course, the original creator is here with, the official citations. So, of course, all credits to Jeffrey for maintaining it. And then, of course, the original creators of Vertigo, the original version of Vertigo. So what we're going to do is we're going to follow this quick setup guide, we're going to clone Vertigo. We're going to get this in. So we'll go ahead and git clone, and then we will follow the next step, which is to do python setup.py, and I'm going to need to use Python 3. Cool. So we've got that configured. We're going to go back, and now I'm going to do Python 3, and we will do, I think it is vertigo.py run. And so I'm just going to hit run on this, and it is not able to because I have forgotten to git restore our source/ticketer to the original unmutated version. That's a small improvement that I would encourage you to make if you're going to use this mutation test script, is that it should put the normal contract back after it's done with all this mutating, especially because you don't want to end up committing a mutated contract. That would just be a big facepalm. So please do not use the script as it is. Yeah, maybe I'll try to make it do that before it's finished. Please do not use the script as it is and then accidentally commit something that was mutated and then let that find its way into production. Please do not do that. Okay, so we should have our good ticketer here, and now if we run that same Python command, we can see it's doing a few things. So we can see, it's giving us some nice logs here, much better than my script that I had. But so we're starting the testing, starting analysis, whatever that might be, detected that it was a Foundry project. By the way, this package will support hard hat and I think truffle as well. And, initializing, checking the validity. And so if you see this negative log with, we couldn't get valid results by running the tests, this means that your tests are failing. So for whatever reason, your tests are failing when they're checking the validity of the project. And so now if I run this again, tests should be passing. And so now we can see that it's actually running here. We can see we are running analysis on 6 mutants. So they came up with 6 mutation versions of our ticket or contract, and then we were testing our contract against them. And it seems like we did get one of them that just kind of errored out. So looks like we caught all of them. One of them errored out, so it just wasn't correctly found, but that's just because it erred. But we can see that, this is a much nicer UI. But if you want to go ahead and roll your own and write your own JavaScript script for, around something that just goes and generates the mutants directly, you will probably be able to get more mutants, because we could see here we got 14, and it looks like here we had 6 different mutants. So potentially some better coverage from Gambit, and then using our own script to sort of splice stuff in. But this is honestly a much better UI, especially to get set up with. So fantastic experience on that end. So that is really how we can use mutation testing, and that's it done with 2 different packages, 2 different approaches. I'd say Vertigo is probably way faster just to get up and running. If you just want it to work, you just want to try it out on a few mutants. And then if you want to go, all out and you want to have as many mutants as possible, probably Gambit is going to produce the most mutants. It might depend on the contract that you're looking at. But another thing I want to add about mutation testing in general is that you don't have to just be limited to testing your normal tests. Like one of our tests here was a fuzz test, right? And we could even implement invariant tests and have the invariant tests be a part of this. So you're really getting feedback on not only your unit tests, your integration tests, but also your fuzzing and invariant tests, which just make all of those different testing mechanisms as testing campaigns a whole lot more effective. Especially, I'm just thinking about, I've only recently just started to really look into, I'm thinking about how we can improve the quality and the coverage of the test suites and the fuzzing harnesses that we make at Guardian. I think this is going to be really huge for being able to get the best, deepest coverage for our fuzzing suites. and be able to sort of force us to come up with really great invariants. Because I'm almost thinking if we force ourselves to hit this mutation coverage or hit as much coverage as possible with these mutants on specifically invariant testing harnesses, I think it's going to force us to have to come up with some really, really smart invariants and force us to basically end up just making really, really robust, really well covered protocols with great invariant testing. So that's just why I'm really excited about this mutation testing stuff. And like I said, it's not really that widely used, at least thus far. And the tooling, in my opinion, has a really a ton of potential to grow from where it is right now. So for instance, this was fine. This worked fine on my ticket or contract, which is, probably all of like 15 normalized Slock. But when you start to get into a contract that is, 500, 600 lines long, when you start talking about multiple contracts, so the compilation time starts to become a real issue for talking about, okay, I've got to take the mutant contract here, I've got to put it into the source directory. Now I've got to compile everything again, and I can't just compile that one contract because for whatever reason, Foundry just seems to really suck at picking the exact contract that needs to be compiled. And, perhaps there's some ways to optimize that. Definitely, please do let me know in the comments down below if there is. I've looked into like the sparse configuration that they have didn't seem to do too much. Unfortunately, a lot of the toggles they have for building doesn't really seem to allow you to toggle, that same stuff on testing. But if somebody knows a way to really filter down and ideally only have to compile that one file when you change it, that would greatly speed this up. But as far as I can tell right now, we're kind of stuck having to compile multiple files every single time we take a mutant in, we put it in. And if you have a lot of code, there's going to be hundreds of mutants. And so running a mutation test could take like literally hours. So I think that's one huge bottleneck on mutation testing right now is just the time that it takes to compile and test each mutant. So I think that's certainly one area in which the tooling really has to improve for this to be widely adopted. And then of course, I think it would be great to have more applications, more packages that are kind of like an all-in-one solution, kind of like Vertigo, that just take like, hey, let's have a really nice UX. It can automatically detect if you're in Foundry, if you're using Forge, and then it will automatically come up with the mutants for you and then run your test suite and all that stuff out of the box instead of maybe having to use your own script or something like this. So those are my thoughts on, what ought to be improved, what could be improved. If I personally find the time, I might go ahead and build out and, make a much better version of what we got here. I think, first of all, with this rinky dinky little script that I've got, it could be parallelized. That could be one particular optimization to be made here where, you could have like 4 processes going at the same time, testing their own cross-section of the mutants. That could speed things up. But beyond that, like I said, I think the compilation time is the biggest bottleneck probably. But anyways, I think there's huge potential here. I think this could really be a great benchmark to measure how ready you are to go into a security review, how ready you are to deploy is, not only like, hey, where's your code coverage at, but where's your mutation coverage at? I think any measurable indicator that we can get is a huge plus because as we know, security is really fundamentally impossible to measure. So anything downstream of that, I think, is great. But with all that being said, I hope this was at the very least entertaining, maybe at the very most educational, and hopefully this will help you go and find vulnerabilities in test suites, and then by way of finding a vulnerability in a test suite, hopefully you can find a vulnerability in the actual smart contract. So hope that was helpful for you. Hope that was interesting for you. And then of course, I've got a shill if you are interested in becoming a senior smart contract security researcher and you want to know exactly what worked for me over, what I found over the past 2 years, what I saw that worked for me that, if I did it earlier, probably would have sped up the whole process. If you want to know what those things were, I just took some time to record an entire video breaking that stuff down. You can go and check it out, put a link to it in the description. If that's something you're not interested in, then that's totally fine. Hope you enjoyed the video. And of course, if you are interested in joining a community of Web3 security researchers and connecting with people across the globe, maybe collaborating on stuff like building out a new package for mutation testing, which I'd be extremely grateful if you did. Go ahead and apply to join the community at lab.guardianaudits.com. Completely free to join, and I look forward to seeing you in there. All right, that is all for this time, and I look forward to seeing you in the next one.